Hi guys, so this video is on triangle similarity. So this is going to use some of the things that we learned about scale factor and dilations. We know that a dilation changes the size of a figure without changing its shape. So that is what we're going to be thinking about as we go through this and think about triangle similarity. Whoops, sorry, give me 1 second. Okay, what does it mean for two triangles to be similar? So if two triangles are similar, that means they have the exact same angles. So all three angles would still be the same. And it means that all of the sides would have the same ratio. In other words, they've all been multiplied by the same scale factor. Okay? So there are three tests that we can use to check for triangle similarity. In other words, if we don't know all the information about the triangle, we can use different things, different tests. Okay, the first one is called side, side, side. If I know that all three sides have the same ratio, okay, then I can say by side, side, side that the triangles are similar. If I know at least two of the angles are the same, okay, not supposed to be an arrow, but it didn't kind of work out. But if we know that at least two angles are the same, then we'll know that the triangles are similar. And the third test would be if I know that there is a side and then an angle between that and another side. So these two, let's see if I have a triangle here and I have a triangle here. If this side and this side are congruent and this side right here has the same ratio, 2/4 is the same as 3/6. If that's the same, the ratio between each side is the same, then the triangle will be similar. This angle has to be between the two sides. So there's a congruent angle between two sides with the same ratio. I'm struggling today. So if any of these three things are true, then I'll know the triangles are similar. Let's see, there's a congruent angle between two sides with the same ratio. Okay, so you're going to be given some triangles and you're going to be asked if they're similar or not, what test you use to determine the similarity, and then maybe what you'll be asked to fill out a similarity statement, which I guess if this were triangle ABC and this were triangle PQR, okay, I would say triangle ABC is similar to triangle, and when I put the next triangle here, I have to have corresponding parts. So angle A here is the angle that they have in common. So it corresponds to angle P in the second triangle. And then B is the side that is shorter between A and B, right? So the shorter of these two sides that come away from that angle that's congruent would be PQ. So Q would come next. And then C and R are corresponding. So if I write this ABC and this little squiggly line and then PQR, that means triangle ABC is similar to triangle PQR. Okay, and remember, similar means they're the exact same shape, but one may be larger or smaller, right? So all three angles are the same, but the sides and all three sides have the same ratio. But if we don't know all that information, this is the minimum that we would have to know. Okay, we would have to either know that all three sides have the same ratio, two angles are congruent, because if two angles are congruent, then all three have to be congruent automatically, right? Because the three angles in a triangle add up to 180. So if I know at least two of them and that they're the same, then I know that third angle will be the same. Or I have to know that side, angle side, these two sides that are that have that angle between them. Okay, I have to know that they have the same ratio and that the angle is congruent. Now, if I had something like this, where I know that this angle is congruent to this angle, and then I knew that this side were 2 and this side's 4, and I know that this side is 7, not 7, this side is 8 and this side is 4. If I have two triangles like this, they have one congruent angle and two sides with the same ratio, but because the side lengths that I know are not the ones that are around that angle, right, they have to be attached to it in order for us to know that these are similar. Okay, so keep that in mind. If I saw this, I would not be able to conclude that these triangles are similar because I only know something about two of the sides, and the angle is not between the two sides. Okay, so let's go ahead and try an example. Okay, what is angle-angle similarity? So we've already talked about it. We have to know at least two angles are the same. And right away here I can see that these have one angle the same, that's 78. Okay, so if I can, oh, actually no, they're both similar. Silly me. So these have 47 and 78. So because they have two angles that are the same, I would say yes, these are similar. And I can say they're similar by the angle-angle theorem. Okay, so yes, they're similar by angle-angle. And then if I wanted to make a similarity statement here, I could say I'm just going to start with one of them and I'm going to do QRS. So I would put a little triangle out here. Triangle QRS is similar. Now remember, I need to have corresponding parts here. So angle Q is 78 degrees, so that would be the one corresponding to C. So I'd have to put it in the same position in my similarity statement. R is 47, excuse me, and D is 47, so that would come next because R corresponds to D. That leaves E for my last angle. So this reads triangle QRS is similar to triangle CDE. Okay, so sometimes you'll be asked to finish a similarity statement or complete a similarity statement. That's what it's asking you to do. Okay, so let's try something else. Let's try another one. We'll use another one of our tests. So side-side-side similarity. In side-side-side similarity, we have to show that the angles all have the same exact ratio, right? In other words, the same scale factor when one was multiplied by something else to get dilated. If all three dimensions don't have the same scale factor, then these will not be similar triangles, okay? So we need to kind of think about right now which sides to match up with which sides. We're going to make three ratios. We're going to be comparing these triangles and their sides to see if we get the same ratio on each one, but we have to compare corresponding sides, okay? So what I like to do is I like to choose one of my triangles to be on the top of the ratio and one of my triangles to be on the bottom of the ratio. It does not matter at all which one you choose to be which. You just have to be consistent throughout the problem. So I like to label it and give myself the best chance of not making a mistake. Okay. Now I see in this triangle here, QRP or PRQ, I have the longest side here is 24. So that's going to go on the top of my ratio. I'm going to compare that to the side in the other triangle that's the longest. And I see that the longest side here is 20. So I am taking the longest side over the longest side, and I'm putting the one I chose to be on the top of the ratio, and the one I chose to be on the bottom. Okay. Now I need to see, does this equal the other ratios of the other sides? Okay. So next I'm going to do the shortest side. So the shortest side here, just looking at the numbers, is 12. So 12 goes on the top because it's from my top triangle. The shortest side over here is 10. And now I need to show, does this equal the medium side over the medium side? So the medium side in the big triangle is 18. and the medium side in the other triangle is 15. So now I can go ahead and plug these into my calculator and see if I get the exact same decimal each time. And if I do, I will know they're similar. If I do not, I will know that they are not similar. Okay. Maybe we'll just try reducing these fractions really quickly. So if I divide 4 into each of these, I'm going to get 8 over 5. So, right, 4 times, I'm sorry, no, I'm going to get 6 over 5. I am struggling today. So 6 over 5. If I reduce this one, I would get 6 over 5. And if I divide both of these by 3, I will also get 6 over 5. So I see that these are all the same. Alternatively, I could have just put them all in my calculator and seen if I get the same decimal, the same exact decimal each time, then I will know they were similar. So because these are all the same, I know these are similar, so I'll say yes, they're similar. The side test is how I knew they were similar. And then to complete a similarity statement, I would say triangle, and I can just choose which one I start with. Triangle KML is similar to triangle. Now notice K and M are on opposite sides of the shortest side. So it starts where the longest side and the shortest side connect. So the longest side and shortest side over here connect at R. So R corresponds to K, so it will go first. Then I went along to the shortest way to get to M. So from R to go the shortest way would go to P and then Q. So that would be my similarity statement. Okay. All right, let's try another one. Let's talk about our third test. All right, so side angle side similarity. Again, remember, if I don't see that the sides that I know are on either side of the angle that's congruent, then I won't be able to use side angle side, but I see that that angle is between the two sides that I know on both of these triangles. So I know that they have this right angle that's in common, so I know that that's congruent. So now I just need to check my ratios, similar to what I did on side, side, side. So I'm going to take this as my top triangle, and I'm going to take this as my bottom. If you did it the opposite way, it would not matter at all. You'll get different numbers, but as long as they're the same as each other, it won't matter. So I'm going to take the long side on my top triangle, and I'm going to put it over the long side on my bottom triangle, and I'm going to see if that equals the short side on my top triangle over the short side on my long triangle. So does 36 over 24 equal 15 over 10? Again, use your calculator if you want to. I'm seeing that both of these have a common factor of 5, so that will reduce to 3/2. And this one is also 3/2. They both have a common factor of 12. 12 times 3 is 36. 12 times 2 is 24. So these ones are equal. So yes, these are similar triangles by side, angle, side. And my similarity statement, I'm going to choose my first triangle to be triangle ABC. It's going to be similar. Triangle A is it is being formed by the hypotenuse, which is the longest side, and then the short leg. So this one, the hypotenuse and short leg come together at X. So X would be the one I put first. I went from A to B, so I went along the short leg from A. So from X, I'm going to go along the short leg, and that will give me Z, and then over to Y. Okay, so that's the similarity statement. So let's just look at a few more examples before we close this out. So we're to determine if these triangles are similar. So this is 4 different examples. So these two are together, these two, and these two, and these two. So first of all, we need to determine if they're similar. Then we're going to write a similarity statement and say which theorem we used. So on this one, I can see that angle A and angle Y are congruent, and also that angle B is congruent to angle Z. So because of that, I can say, yes, these are similar by which theorem? That would be the angle theorem. Okay. Now I just need to complete my similarity statement. So I'm going to say triangle ABC is similar to triangle. A is the is congruent to Y, and then to go towards B goes toward the other congruent triangle to Z. So is similar to Y, Z, X. Okay. On this one, I know that they have one angle in common, 81. This one's 40 and this one's 60. But remember, the three angles in a triangle have to add up to 180. So I could find this other angle. This other angle is going to be, looks like these two together need to be 99. So this one would be 39. Okay. So that makes this one over here 60, 59, 59. Okay. So there are not two angles the same. They have one in common, but they do not have two in common. So these are not similar. Now, if they're not similar, you don't need to tell me by which theorem, and you do not need to tell me the similarity statement. Just say they're not similar. Okay. All right. So on these bottom two, we can go ahead and check. It looks like I'm cutting off a little bit, so let me pause this and fix that. Okay, there we go. So we have an angle that we know is congruent, and so we're going to go ahead. I have a fly attacking me. And so we're going to go ahead and we're going to check for side angle side. So in order to do that, I need to choose a top triangle and a bottom. I'm going to choose this one as the top, this one as the bottom. I'm going to put long side over long side, so 4/8. And then I've got this leg, I'm going to put 3/6. Both of those reduce to 1/2, so those are equal. And because that angle is between those two similar sides, then yes, these are similar triangles by side angle side. And I can't complete a similarity statement because these triangles are not labeled, but you could if they were, right? So we'll just skip that step for these last two. This one I'm obviously going to be checking side, side, side because I don't know anything about the angles, but I know all three sides on both. So let's put this one on the top and this one on the bottom. If you want to pause it and try it out on your own and then compare, that would be probably a good idea. Again, it doesn't matter which one goes on top and which one goes on bottom, as long as you're consistent the whole time. So I'm going to take my longest side first, which would be 20. Over the bottom triangle's longest side, which would be 25. And I'm going to compare that to my shortest side, which is 16, over my shortest side on the bottom triangle, which would be 20. And I'm comparing that to my last one, which would be 18 over 22. So go ahead and reduce each of these fractions. 20 over 25, they're both divisible by 5, so that would be 4/5. 16 over 20, they're both divisible by 4, so that would be 4/5. And 18 over 22, they are both divisible by 2, so that would be 9/11. So that one is not equal, which means these triangles are not similar. Okay? So go ahead and give them a try. If you have questions, please don't hesitate to email me. We can always get together in a Zoom call if you need to. Just let me know. Have a great day.